walking into our test area bay. This is where we do vehicle evaluations. So if we get a vehicle that's brand new and we need to establish the voltages from the source unit, if it's got CAN bus, if it's got obviously crossovers built into the OEM amplification, if we need to start figuring out any kind of integration CAN bus conversion units, what they're going to do, what language they're talking, and whether in fact we can include subwoofer locations without damaging any part of the warranty elements to that vehicle, because that's one of the biggest things. So in this room here we do a lot of testing, and we're going to talk about this when we get in here. We actually got a vehicle in here at the moment that's had a system done, and now we're doing a post evaluation, and we're doing some fine tuning, some equalization, because sometimes we'll need to process stuff to correct some of the vehicle interior, which is sometimes a challenge in the sense that the factories obviously have had that processor established within their amplifier, but now we've gone and amplified the system with obviously better speakers and more power and more bass. And we want to fine tune that for clients and specific tunes. And those tunes, we then keep those on a flash so we can upload those to anybody's particular tastes. So this particular vehicle is it's a Ford Ranger. As you know, we do a lot of work with Toyota, Ford. We're now getting Havals. We've got Jeeps. We've also got Suzukis. So this is what we do in this room. So follow me through. All right. So this room is also used for training. We do training in here. We have seminars. We're actually going to have Brian Schmidt coming out here very shortly. We're going to be using this room where we set up with chairs, and we're going to have the workshop next door, which we do Top Gun. Well, Top Gun for RTTR, and we do mobile solutions, which is what Brian Schmidt comes out for. And Brian Schmidt, if I haven't mentioned it already, is like, in my mind, the rock star of fabrication. I mean, he's, rubbed shoulders with guys like Chip Foose and Dave Kindig, and that's just to mention a few. Known Brian for many, many years. He used to run the RTTR at Rockford Fosgate many years ago. He's now started up Mobile Solutions. I think it's probably on to 15 years, if not longer. And we're very fortunate to have him in our circles. So he's coming out here in April. And we do this not because we sell training. We do this to add value to our dealers. So essentially we sponsor 85% of the cost to come out here, the equipment, Brian's time, which is very valuable, and most importantly, so that we can create better chefs. The ingredients are the products, and we have the very best. Recipes are putting it together to suit each vehicle, but then you need the chefs to obviously create these things into the final product, and that's exactly what AMD's DNA has been from 35 years ago. So with no further ado, let me start talking about what we do here. So for example, this vehicle now, we're coming in and we are doing some phase detection evaluation. This is a phase detector PD1. Some of you might know what it is. Now, a lot of people use this device incorrectly. They use it for checking phase at the speaker, okay? But actually, that's electrical phase. Acoustic phase is actually at the ear. So now what happens in this particular car, we got a woofer, which we've designed the enclosure for. It's under the seat. It's a P3 shallow. We have 3 stages. We have stage 1, which uses a prime 10-inch. We have stage 2, which uses a P2, and we have stage 3, which uses a P3. That enclosure is slot vented. We've got another enclosure we're busy developing at the moment. The factory has a little, 6x9. It's almost like a 5x8 really, that goes behind the back. It's a plastic thing, which is understandably for factory, it is fine. It's great, but from factory point of view, let's be honest, it's a damn good system. But as you know, consumers want more, they want more power, they want better, because they expect, they're demanding. So this particular client, he listens to FLAC files, he wants the very best from it. So this vehicle's had obviously all the sound deadening treatment you can hear. There's absolutely no tinny sound here. Whereas the back, being the bin, that's what the door would have sounded like. So that's kind of, you don't want your speaker to be playing in there, you want your speaker to be playing in here. So we've created this to be an enclosure representative of a hi-fi speaker. Even the door cards, we've got silent coat foam which goes behind the plastic, because you also don't want any back waves to resonate. And obviously we'll show you later on the spaces. So we develop spaces for these. There's no cutting, there's no drilling. It's the original factory locations, original factory plug, everything is original. That enclosure can come out and literally everything can go back in as it would be. So there's no way, if this car is closed up, would you know that there was an upgraded system. In fact, our cameraman here climbed in here this morning and he thought this was an OEM system. And he goes, why would the guy want to change it? It sounds damn good. I said, well, it's because it's really an upgrade. So we take these vehicles brand new. We thoroughly investigate the harness. We'll establish what connects to that factory radio. We don't even remove the radio. We literally pick up where that umbilical cord, if I can call it, connects to the factory amp. We then get the right device. We then preset that device. So when it goes to the dealer, they've already got the loom made up. Everything is designed to work and integrate into this vehicle seamlessly, even down to the grounding points. We can't just drill a hole anywhere. Front door is much the same. They take 6x9s. We use, in this case, this is a power system. So there's power 6x9s up front here and power tweeters in the factory locations. And then of course the doors again, are solid. Even underneath the woofer location, if you look in there, Mr. Camera Guy, you'll see it's also deadened. Even through that little hole, you can see through that hole. You'll see it sound deadened underneath there too. So even where you don't see, it's completely dead. And that entire enclosure, it's very important to have that. So yeah, if you drop the seat down now, obviously you'll see everything goes back to standard, and there's no way of knowing that there's a sound system in here. Anyway, the solution also for another videos we spoke about, we have swing cases which go in the back for your jacks and stuff like that, which I think you may have seen on a previous video, but if anybody doesn't know, we'll put a little insert at the bottom here and you can see what a swing case does. Getting back to the vehicle tune, so yes, phasing is very important, because what happens with phasing, yes, electrical phase is essentially the input signal has to be the correct phase from the input source. In this case, it's coming from a PAC4, which is a CAN bus interface box, which takes the digital language, converts it into analog. That is absolutely critical that input phase is correct, especially if you're bridging an amplifier. Now, some people think you've got to have a mono amp for bass. That's absolutely not true. You can take a stereo amplifier and bridge it. Essentially, it sums both left and right into one channel, and that can be very useful when you've got a specific impedance woofer. Now, example, if you took a mono amplifier and it was and a 4 ohm sub, well, guess what? You've got a problem. You're only get 4 ohms because a mono amp only sees the same load. A stereo amp sees half the load. So in the case of taking a stereo amplifier and bridging it, it will then see 2 ohms per channel, which will produce more power. Now, so people always say, you've got to have a mono. Well, it's ideal, but the thing is, you also got 5 channel amps, and one of those channels could be stereo. They actually call it mono, but it's actually pre-internally bridged. So you've got to be careful with that. And also, a lot of the woofers these days, especially ours, are all dual voice coil. So you could take, for example, a dual 2, run it into series, which will be 4 ohms, and then you could bridge it on a stereo amplifier, comes back to 2 ohms. Or you could take, our power woofers, you get them in 2 ohm and 1 ohm. Now, that's where you definitely want to run a mono amplifier, because although our power amplifiers can quite happily run 1 ohm properly, not just stable, they are engineered because they have constant power circuitry, which enables them to produce the same power constantly at 1 ohm or 2 ohm, irrespective of frequency, as I demonstrated in, I think, in one of the other videos we spoke about it, where constant power has a technology where music obviously has changes in voltage, and of course the amplifier would be, as a result, with a woofer or any speaker that matter, with an impedance moving up and down, it'll change the output voltage. With Rockford amplifiers, they keep that voltage 100% constant, which means your music output is always going to be stable. And that's what people are trying to emulate. If you played a note on a guitar or a drum, you're not hearing any variation in volume. It's coming to you from that instrument in real time straight to your ears. And that's what Rockford Fosgate amplifiers are designed to do. It's a patented circuit, very clever, besides many others. Yes, so getting back to the point of phasing. So input phase is super critical. So you start with a signal and then you get it to the amplifier. Now you got the input right. Okay. Let's just imagine you had the left and right phase incorrectly done on a woofer that you're going to bridge. There'll be a problem, because now it's going to cancel no matter what you do on the output, it's going to be cancelling out the internals of that amplifier, because the preamp is now telling the output device to play the left out of phase with the right, which ultimately creates a null. But let's assume you got that correct. And you got the woofer phased correctly and everything's fine. The biggest problem is reflective waves. Now you've got the crossover in the amplifier, which creates crossover, especially 12 dB per octave. By the worst, they have 180-degree phase shift. So that creates a 180-degree phase shift in itself. Then the position of the woofer under the sheet, bearing in mind it's getting compression waves, by the time that woofer arrives at your ear, it's probably changed phase 3-4 times. by the time it's gone through the processor, it's gone through the amplifier, it's gone through the crossover, it's gone through the position of the seat, the angle is now 90 degrees out of phase to the front. You have to get phase alignment to the front stage, because if you don't, what will happen is only when you're putting your head forward will you get bass. If you're putting your head in the center, it's out of phase to the front stage. Big problem, but we have the instruments to do it, we understand it. We also use a real-time analyzer, which is the real story. It's right across over there. We'll put it in the vehicle shortly. And what that does, it confirms what we're hearing. And basically, it's a tool that converts sound into a picture. And that's the only way to really know. So if we saw there was a dip, so in this case, the vehicle's probably crossed over at 72 high pass, 72 low pass on the subs, which means that we've now got, if we had two of those out of phase, you'd have a massive hole. Whereas if they were in phase, the crossover would show you that the response curve, and that's a 1/3 octave equalizer, sorry, 1/3 octave crossover. Let me get that right, sorry. Bleep moment, spectrum analyzer. So it'll pick up every single frequency right across a 1/3. In fact, it goes up to even further than that. It goes to quarter octaves. So you can really, but we only run a 1/3. You're not going to hear a quarter octave individual response curve. So individual LED settings. And if you're running a real-time analyzer together with a 1/3 octave equalizer, it's a beautiful machine to have, because you can literally see every single frequency and how you're having a response to it. Now, it might be the input, maybe there's a pre-built-in EQ. You can see that. You can measure before amplification what's going on to see if the head unit's got a flat response. You can also measure output, where each speaker maybe has a crossover that's got an issue, and you don't know whether that's the cause of it. Ultimately, what that's going to do is sum up and tell you, and you can backtrack every single stage of the signal chain to see where the fault is, electrically and acoustically, because we can feed audio straight into that RTA, and we can see the picture real time. And we can decay it also into 20-second delays, and we can see it slowing down, which makes it a lot easier. Obviously, in real time, we can compare the acoustic output through a microphone and compare it to the electrical input, which is basically straight into the unit. And then we can start looking at the differences or differentials between those and saying, you can see the gain overlap between the vehicle and what was being absorbed. And then you can start realizing, well, where do I EQ, where do I cut? And typically people think they can EQ the crap out of things. You cannot do that. You can boost about 3 dB, otherwise you start adding color to the sound and distortion. And you want to rather fix the faults. And then if you have an issue, then you can start looking at speaker placement. And if you have to cut back, absolutely, but do not boost more than 3 dB ever. So I'm just, going on touching on a few subjects. I don't want to get in depth. We could be here for days. But if there's anyone out there that wants to talk about any particular point that I've mentioned, please make a comment, send it out there. We're happy to talk about it. We've got, absolutely our intention is just to provide the best information. So when people are buying sound systems, they're not going to go into a store and just buy an amp and speakers and have some sales guy fill in with garbage about, this is so many watts. We'll get onto that subject another day. Because remember, I talked about current. Currents, if you go back in some of the previous episodes, we spoke about current and what an amplifier truly does. Because people think they can just elude you by saying this is 1,000 watts for whatever money. It's not smoke and mirrors. It's just like buying computers. You understand there's a difference, or buying cars, or any component that you purchase from TVs. We all know there is no free lunch. You buy cheap, you get cheap, and ultimately you pay the price. So yeah, that RTA, so Dinesh over here is basically going through the tune. He's validating the crossover points. So we obviously designed these systems, but this particular one, it wasn't delivering what it should. So we take it very seriously, and we want to make sure that every dealer can be consistent so that every consumer has exactly what was expected from when that engineer developed Rockford Fosgate, right down to the last terminal, the last freaking screw has to be perfect. And that's the goal. There is no compromise. Just like when you buy a car, it's got to be consistent. Let's take a walk over this side. And yeah, so this is the real-time analyzer. Here's the microphone. This is a microphone which is designed to essentially pick up frequencies well below our human hearing. So it'll go right below 20 hertz. This analyzer goes down to 20 hertz up to 20,000. So we typically hear between 50, 45, 50. You'll feel bass at 40. My age, I'll be lucky to hear past 15. I mean, SPL and abusing my ears. Okay, so we're doing a phase check here now. Essentially, the back speakers if you go to the back speaker, we're going to show you now what's actually happening. So it'll just kind of be a good demonstration to show you. And if you look at the seats in vehicles like this, they're pretty much over the back speaker. So your hearing, is going to be more sensitive to these back speakers. So we drop these down around 6 dBs. So that's equivalent to, halving the power twice, which is required, because if you don't, your front stage is going to be affected. So if you go around there, checking the speaker directly in front of it, and we're getting an out of phase pulse. So it's 2 blanks, 2 reds, 1 green. Now we're going to close the door and take this microphone and position it at the ear forward, and you'll find that it probably corrects itself. If you can go around that side, and then you'll have to jump in there with the camera actually. Yeah, so that, as you can tell, now what's happening in this car is that the wave is hitting the windscreen probably, or the back seats, and a whole lot of things are going on, and that's why it comes back in phase at your ear. Now, that's called acoustic phase, and most people miss that. So the front speakers, on the other hand, probably wouldn't have such a long path to go. They're not going to be affected. So you might have these in phase, and it'll come acoustic to your ear. So we've now got these spliced, and then of course the subwoofer has to arrive at the same time as the front. Now we've got devices on a lot of our products. We have DSR1s which have time delay. We've got audio control which have time delay, and we also have Audio-Tech Fisher processors. And all of these devices are specifically intended for whatever application you need. You can't just go and chuck any processor in DSP and say, hey, I've got a DSP. Most people don't understand what those things are intended for. And some of them require to have summing, some of them are required to have obviously phase correction, some of them will have proper equalization, some of them will have the ability to have what's called, take for example, constant Q. Constant Q means when you're adjusting one frequency band, it doesn't affect the neighboring one as dramatically as a parametric, which essentially will have as you increase it, what it does, it goes like this, and as you decrease it, it goes wider, which means whereas constant Q stays in the same parameters within its band. With that said, phase alignment or phase it can be done in degrees. Now, if you wanted to get this perfect, because you wanted to get that bass and the front exact, you can delay the front speakers. You can't speed up sound, but you can delay it. You can delay the front. We can also delay left and right so that you can create a center image, so that what happens with the speaker that's further away from you can be delayed. Sorry, my apologies. The speaker that's closest to you, my apologies, will be delayed marginally, so that, and we're talking milliseconds and just a small increment, so that the stage image, the vocal point, comes from the center. Now, a lot of these vehicles do have a center channel, and you can bring that into the electronics, but sometimes that becomes an issue because your cell phone and all those kind of things are predominantly used from that. And I mean stereo, and you're trying to create a phantom stereo from the combination of both left and right. That's where tweeter locations are good. This has got the B&O label on here. Obviously, these are no longer B&Os. They're actually just factory speakers it's actually made by Ford Motor Company. B&O tunes these cars, and they get paid for the royalties, as we do with some of the factory systems we do with Mitsubishi. It's also the same thing. So we've got a legitimate Rockford Fosgate product in here. It's not some factory paper cone that's just been labeled. So I think we've got the phasing right. Have you got the phasing right here now? So this car should be kicking.
I just got to do the subwoofer.
Okay, and then we'll have the phase alignment. We'll double check it again with the phase detect. Then we'll put the RTO in here and see if we're getting a full response. And if we do, we know we're on the money. And that's what people are expecting. It's like you cannot tune a car like in the old days with a carburetor and a screwdriver and your stethoscope. That's what people think. This is done with instruments, and we've got to have the instruments, and you've got to know how to use them if you want to stay in the audio industry. Because a lot of companies just think, I can wire up an amplifier and bolt it in and gooi a screwdriver and does a bicky bus and I say, So speaking South African. But yeah, that's the truth of it, man. It's got to be done. There's a science to it. So if any kids out there want to follow this industry, we've got a training school. Study in your maths class, study in your science class, listen to your teacher. A lot of shit goes down with this stuff, so you have to pay attention. And it's exciting, it's great, I love it. I've been doing it my whole life, and I wouldn't change it for anything. Say life's too short to listen to bad sound. So yeah, anyway, all good. So we'll catch up in the RTA in about 3 seconds. Okay, so system's now configured nicely, the phases aligned properly. Obviously, one of the things that factory sound doesn't have is proper low bass. So we've got a real-time analyzer here, 3055, which is on the left there. It's an old school device, but it's a reliable hardcore device. Doesn't need an extra computer. Basically, it's a computer in itself. That thing will measure not only SPL, like I said earlier, it'll also do real-time analyzation on input voltage through you can do it acoustically or you can do it electrically. It tells no lies, it tells the truth about what you're hearing. Even if you think you heard something or believe something. This is, we have a compression microphone which is used through Term Lab, which we're the distributors of as well as audio control. So all the test instruments, we have certain places for it. So what this is going to measure is, now we're just playing a track here which has got low frequencies and which you would never hear from a factory system. Understandably, they haven't got, they've got to build it within a budget. So what I'm going to do is I'm going to run a few SPL tests. We'll do the same test with the same track in a factory system versus this. Now, the measurement position is typically 1 foot away from the A-pillar, about 2 inches from the dash. And that's how you establish it. So I'm going to have to do this test just with music. I can play tones, but that's not what we're going to do. I'm going to play the same track, same volume, and then I'm going to play maybe 2 or 3 tracks. And then I'm going to obviously show how much power is coming out of the woofer. We'll take the same microphone, we'll put it at the vent to see how much power we're actually getting out of a little 10-inch shallow in a pickup truck under a seat, completely hidden away with just one little tiny, the amplifier, the footprints on this thing is about that big, and drive the entire system. So let's just do it. So if you want to jump in the back, Mr. Cameraman. Okay, so we're going to turn it up.
Oh, I'm in pieces, it's tearing me up, but I know a heart that's broke is a heart that's been loved. So I'll sing hallelujah. You are an angel in the shape of my mom.
So we got 120 dB right on the dashboard, and people might say, "Oh, that's not much." Bearing in mind, this is not a calibrated instrument. And the only reason why we stopped using it was because car SPL has been up to like 180 dB, and those diaphragms literally could not deal with that kind of pressure. So then, we moved on, and Wayne Harris, also a good friend of mine, and as I mentioned earlier, we distribute Term Lab, which is not only for enclosure design program, but also for SPL measurement. They use a sensor microphone, which is designed to deal with way more pressure. It's the standard, so obviously we're not trying to show that this car is beating world records. We're just using this as a constant to show the difference between a factory system and this aftermarket system, which has got it's just got a punch P3 shallow. It's not even the full-blown system. But trust me, factory system, 3 dBs is doubling the power. If you get a 6 dB difference, you're doubling it again. So, but besides that, it's the frequency response. And that's what the microphone is demonstrating. So hope that explains what we're doing here and makes a better understanding. So there we have it. You've got 138 dB from a factory system without any part of the vehicle having any detection of a sound upgrade. There's the factory standard battery. Obviously, I've showed you the enclosure. The doors are deadened. And like I said, we can take this entire system out and put it back to original with not even the plugs are cut, nothing's cut. There's absolutely no detection of the system being upgraded, which I think in this modern world, people are concerned. This is a $1 million truck, so I certainly want to have my truck, molested, cut wise, and, knowing that someone's gone and, taken away from its original design engineering and as well as its, value for that matter. The last thing we're going to do is put an RTA in here. We're going to just run a pink noise test. We're going to see we have all the frequencies, all the good stuff. So what a pink noise test does, basically it plays all frequencies at the same time, at the same level. Now, the acoustic elements of this vehicle will play a role, bearing in mind the human ear also plays a role. So when you tune these things, we have an efficiency at about 1K, but we also have a deficiency as frequencies go lower. So we will emphasize low frequencies to compensate for the human ear, which obviously has its own equalization properties. So we call that weighting. So these microphones are weighted to some degree, but obviously when we tune these cars up, we understand that. And yeah, that's for the SPL tests, and we'll do an example of the exact same songs in a standard vehicle, and you can get an indicator, because you can't experience this listening to it on YouTube or whatever, but at least you can see the instrument. There it is. The instrument was set exactly. No smoke and mirrors. We're just trying to give you guys an opportunity to understand the level at which we go to give you the very best experience in your daily drive. And I mean, trucks are popular, be it a Toyota, be it a Ford, whatever. It can be a VW, a Isuzu, whatever. We don't just throw you out ingredients. We give you the recipes, and we provide the chefs to give you that experience. And hey, our dealers are graded according to skill. So if you want the very best, you are going to pay a little extra, but hey, it's the same as a restaurant. You book that table, you're going to wait for it, and you're going to experience proper food. It all comes out the ground in the same way, but how it's presented, different deal. And that's what we're all about at AMD. Okay, let's move on to the RTA test. We have the real-time analyzer set up now. It's in RTA mode. We took it off SPL mode. It's got real-time, which is there, and then it's got medium, and then it's got slow, which gives you a decay. That's real-time. It's 10-second delay, 20-second delay. Anyway, we'll go into real-time. And if you look at this, it's telling me that we've got bass coming right down to, what is this here, 50 hertz, and it starts rolling off, which is understandable because we've got a 10-inch shallow woofer. We haven't got a 12 or a 15, but that's where most recorded music is. And if I slow it down, you'll see it starts dropping off. Now that's where the human ear is less sensitive. It drops down to the mid-bass. We have a bit of a hole here at 630, so we have got a mid-range adjustment in that on that factory head unit. We don't have a DSP in here. We could, if we had a DSR1 or an audio control or one of our audio techs, we could correct that. And we could probably bring this down. But what we are seeing here is that the phasing on the mid-bass and the sub is correct. And here's your mid-range and highs that are good. So we can just go jump in there and see if we can get the mid-range fixed a bit. It actually picked it up. So this particular head unit's picking up at 1.2. So we have a bit of an issue down here. I'm not sure what it is. It could be, who knows? At this point in time, it's obviously not a critical mass thing, but if we had a DSR1 in here, we could pull these down. So as you'll tell, between where it was, so I'm going to pull that 1K down again because it's actually giving us the wrong frequency. Now you can see it looks a lot smoother. So actually that's a lot better. So I've actually pulled it past the 0, which is probably because the factory radio was tuned, well, the response curves were tuned for factory speakers. Now we probably don't need that much mid-range. That looks a lot neater. It's not the perfect curve, but at least all the frequencies are there and they're mapping together nicely. And this is the kind of thing that any professional car stereo installer should have. If they don't have a real-time analyzer, a proper one, not just your cell phone, a proper SPL measuring tool, you're literally starting off on the wrong foot. It's like going to, like I said earlier, having a stethoscope and a screwdriver to tune your car. In this day and age, we all know it's got electronics, it's got fuel injection. It's not just, well, okay, it sounds okay, a little bit more advanced. So moving out to the front here, you'll see we have this device which is called, essentially it's an amp clamp. And what it does, it goes over the main power cable. Now what that does, it enables us to establish how much power. A lot of people will go and throw amplifiers in vehicles and they'll go, oh cool. What they don't understand is that the amplifier doesn't produce sound from thin air, it produces it from a DC source. In this case it's the diesel truck, it's got a decent battery. But it doesn't necessarily mean that the battery was intended to drive a lot of other accessories. And also you have to have an alternator to replace this energy. So if you can, draw power from the battery, that's great, but what replaces it? So a lot of the time with, all these fancy electronics, there's a lot of power required. Most of the time in diesel is to start the vehicle, which is why they have a bit of but a lot of these batteries obviously aren't also designed to provide power on demand. They're designed to give you power for short bursts. But with music, it's constantly drawing. Obviously, it's not a drag like SPL where you're going, hitting a note. It's playing music, so which means it's hitting and recharging. The problem with a lot of these batteries, they don't have the ability to recover quickly. That's when good amplifiers are put in. So Rockford, back in the day, and a lot of companies still use capacitors, a lot of the big systems do. Our amplifiers are so efficient and so intelligent that we don't really need capacitors on the mini power amplifiers, especially if you've got a reasonably good reserve, because they both know when it comes in, it's the internal of the electronics in that amplifier will deal with it quite satisfactorily as long as it's got a good reserve. If the reserve isn't good, well, there's a problem. So what we do is we take this device, which is a TPR. It's got a built-in oscilloscope, and it's also got an impedance meter, and it's got a voltmeter. It's got a bunch of tools in it, very, very high-end piece. What this does was we do about 20 tests, and one of the tests are how much current is going to be pulled from the vehicle stationary with headlights on, aircon running, wipers going, just stationary, what it would provide. Okay, and you've got to watch that. So essentially what it's doing is measuring your current drop. And then we'll do a test with it running, and we'll do the same test again. So obviously the alternator is now coming into the equation, and we'll see how much differential between the alternator as well as the battery. And then of course we'll start doing other tests where you're simulating the normal use of the vehicle, driving at night, wipers going, headlights on, windows going up and down, stereo playing. And then you've got to start calculating how much extra, and I'm going to tell you this, it works out to wattage, because we have a formula which essentially gives us the amount of wattage left over that you can then put onto the system. So you can't just go and throw a 2000 watt amp in, although that's smoke and mirrors. A proper RMS 1000 watt amp is a beast. I mean, what you heard in this vehicle now was 50 by 4 RMS. I think on the base amp we're probably listening to 100. So, that's genuine RMS, and we spoke about RMS and what that means in terms of efficiency and how much power you get from a speaker in terms of audible watts on a previous show. So if you want to go back and have a look at that, you can obviously get some of that questions answered. But most importantly, in a car like this, if someone was to go and throw in a cheap amp, and they actually didn't have an extra bit of the extra bit of wattage or current available, which is worked out, we work it out in 2 watts for the fact that people can understand. I got a 1000 watt amp, it's genuine RMS, how much current is it going to produce? How much power do we have in reserve from this factory system to feed that amp? There's no point if you're trying to get a small woofer. Now remember we spoke about enclosures getting smaller because the woofers are getting less efficient. As they get less efficient, the enclosure gets smaller. You can run them in smaller enclosures, which ultimately means you can get lower, which basically is because you can get lower frequencies because the cone has more mass. What that means is you need a lot of power to move it. In order to move that cone, when it's not efficient, obviously means it's going to draw a lot of power. Hence, it comes back to the battery. And that's what I'm talking about. The charging system is critical. No one does that. They just go and chuck it in, hope for the best. Another problem is they might pick up a power wire from the battery post. What about the ground? The ground here is grounded to the vehicle. It's got paint on it. Now at the back, they might go and say, oh, cool, I'm going to put a nice ground in there. Maybe they do find a good spot if they've taken the time. But what happens if this ground is not sufficient to feed the body? Now remember, they're not interested in whatever feeds at the back. It's all about, the ground point here is mostly for the starter motor, and there's one which goes to the fuse box, which feeds the lights. But that's what the car was intended to do. Take a multimeter and establish, is there any ground resistance between the supply of the battery and the amplifier ground? Another thing, trained, authorized Rockford dealers have been told and understand how to do this because you're getting the maximum power. And that's just a couple of small things. When we do our trainings for 3-4 days, we get into a lot of detail in terms of, acoustic engineering and time alignment and different types of phase alignment and, the crossover slopes and how they have an influence over the ultimate, money seat, and that's the driver's seat. So, and then if we move around this side, we've got other instruments which we typically use. So this is our, as I said earlier, this is our setup room. It's also used for trainings. We haven't quite finished it. We're going to put up a monitor over here so we can plug DSPs into the car and then watch them up on the screen. And then that way we can obviously fine tune it remotely and obviously get these things perfectly done. And we'll map those fine tunes and we can emulate them into any other vehicle. So here's some other tools that you need. This one here is a distortion detector. The guy who developed this is Tony Diamore, a good friend of mine. Anyway, this is a very interesting tool because what it does, it tells you more accurately than a 20K scope, which is the standard instrument. Most people aren't going to take a big oscilloscope, put it in a car. What this does, it'll tell us if we're getting distortion from the source before you amplify it, at what level. Then it'll tell us after amplification, because if you're setting up a system, you can't set the gain and hear distortion. Yes, you can hear it on mid-range and tweeter, but if you can hear it, it's too late. It's already too late. The distortion creates heat, which burns speakers. I don't know if we've covered that in brief on a previous show, but if we haven't, we can get into it. I think we might have to do that in one of them. I think we discussed it briefly, and heat is the enemy, and ultimately, that's the biggest problem with speakers failing. Anyway, so what this does, it accurately tells you exactly at a frequency, obviously 1K is the middle frequency, 40 Hertz is the low frequency, and you can work it out. And what we do is we feed, and if you feed 0 dB into it, you've now got a nice audiophile system. If you go -5 or -10, you're now creating an overlap, which will enable you to have a bit less headroom. Obviously at 0 dB, which is the maximum recorded voltage you can get on any recording. So that would be the audiophile purist. But then you're not going to get that extra bit of power that you would want. So normally we'll go -5 on our input voltage, on our input signal, and then we'll do -10 on the woofer. So if you go -5, you'll get a nice sort of happy medium between. There is a little bit of clipping in there, but it's not going to be harmful. If you go anything, more than that, you're going to have issues. And that's a typical setup, like I said, -5 on 1K, -10 on 40 Hertz. And that's what this car is mapped to. It gives you a nice happy medium between the human ear deficiency of low frequencies, which you saw on the screen. This next device here is called an impedance meter. Now what this does is quite an intelligent thing. This can work out the enclosure volumes. You can literally take an enclosure of any volume without knowing the size, plug it in through a known woofer. It'll establish the resonant frequency, the tuning frequency. You can chuck it into Term Pro, the data, and it'll work out to a freaking minuscule of a liter, like down to a 1/10 of a liter of exactly the volume of that enclosure, 100%. No freaking throwing water in it and taking guesses and all that kind of weird stuff. But what this does, it basically is an amplifier. It lets you see on the screen, unfortunately there's no battery in this one, but we'll put it up on the screen to show you. It lets you see in real time what an amplifier is seeing when it's playing in your system. So if your amplifier is getting hot and, for example, there's a tweeter that's burnt, and you wouldn't know, because if you put a multimeter on a tweeter, through a crossover, it's not going to show you anything because a multimeter won't measure through a capacitor. It has to only measure at a tweeter. So most people would be like, well, I'm just going to go and measure the wires of the amp. Oh, it shows fine, 4 ohms. Great, but the tweeter's burnt. Now, of course, it's playing into a 0 ohm load when it hits those frequencies. Now the amplifier overheats, shuts down, and people are saying, oh, I don't know what's wrong, blah, blah, blah. This thing, you can literally frequency sweep it from 16 Hertz right up to 25,000, I think, and you can see the impedance at every single frequency. Now, obviously, people think, oh, it's all 4 amps. No, it's not. Every single frequency has a relevant to a different impedance. And then you can see that if the crossover, if it's well designed, if the speaker's well designed, you can obviously establish the tuning, if there's any gain, if there's any crossover points that are too far apart. Because if the speakers are obviously, let's just say the enclosure is too small and it's rolling off too quickly, and now you've got a mid-bass driver that can't pick it up from there, there's a bunch of things it can do. So besides volume enclosure calculations, it's also a frequency generator. So you can use it for establishing rattles in cars. I can establish, if there's a rattle, like this car, I picked up a rattle, turns out there was something in the center console. So you can run frequency sweeps and in a minute you can figure it out. So, and that way you can work out standing waves, there's a lot of things. Besides, obviously, is emulating faults from an amp as well. If you run it from the output of an amplifier, it'll tell you exactly what's going on in that vehicle before you strip the single thing out of it. So that's the IM1. This guy over here is a crossover calibrator. Now here's an absolute necessity. This device here is, I don't know how people used to do it in the day, because Rockford used to have crossover cards that you could literally pre-set the exact frequency. People got, well, it's a schlep, we don't want to do it. So you have a pot. There is no pot, period, that you can set where the marking on the amplifier is what it says. I can guarantee it. If you find one, I want to see it, because I've yet to see it. There's just no way. With components never having the same tolerances, the fact that that's screen printed on, it's just not going to happen. So now you go and put an amplifier in a car and you go, oh, I want to get 80 Hertz. You dial it in by R. It's literally like taking a screwdriver and saying, oh, I've tuned the fuel and air mixture, good enough. Without an instrument, you're not going to know. What this does, you can tune it in to the exact, and we'll show it up on a video, a little insertion of how it works. It's so easy to do. You put it on the amplifier, you literally disconnect all the speakers, which is the same you do, by the way, with the distortion detector. No speakers are on. It literally creates the same load that the speaker will do, which is a little interesting, because if it was there's a little sum you got to do. If it's a A loosely regulated power supply, which means what that has, I have to just touch on this, it means that the amplifier produces more power when it gets more DC voltage. So as the voltage goes up, the output goes. If it's a fixed voltage regulated amplifier or fixed regulated, it stays the same. Whether it's got 14 volts or 10 volts, it's the same. It's good and bad to both. The difference is, obviously, when you're using these tools, the distortion detector, you've got to read the manual and take that into consideration. But that's just something you want to, just on the side note. So coming back to this, I can set it at 80 Hertz, play 80 Hertz, turn that pot, and you'll see it's got three little lights. They go, I think it's green, and the blue one is the center one. When it hits center, it's calibrated, done, spot on, 100%. There's no, it's locked in, done. So we can put a seal on it, and we'll know that that system is tuned properly to the frequencies that we intended to match that speaker. So we've got a 6x9, we might go at 72, because it'll obviously handle the lower mid-bass frequencies, of the sub will be 72, so you don't get point sourcing, which is essentially hearing any vocals coming out of the woofer. Bearing in mind, we've still got a seat over it, which is creating a 6 dB slope mechanically as well. So there's a lot of things to take into consideration. So, and then of course the phase detector you saw. So this is just some basic tools that every professional installer should have. And most importantly, know how to use them and use it on every single car. Because people are just like, yeah, I've been doing this for 25 years. I can just throw an amp in and turn the screw and it's like proper. You know what? Bullshit. I can tell you right now, we've had trainings with salted installers. When I say salted, they've been around, for a while. And we had them in groups of 3. And we said, right, tune these amplifiers. And we said, right, you happy? We went back and checked them. Every one of them was 20% out. That was the closest. I think the closest was like 20 to 50. Average was around 20% out from crossover and gain. Now, how can you expect people to pay all this money and then, the system's not optimized? It just doesn't make sense. So if you want to do an installation properly, invest in the tools. As authorized Rockford distributors, we obviously train the dealers to do it, and that's why Rockford, Fosgate and AMD has a recognized reputation for doing things correctly. We're not saying that we're perfect. We're not saying every dealer does it perfect. But trust me, if they're not, we take note of it and they agree. So if you go on our website, you'll see dealers are graded from, standard plus, premium. Nobody has quite reached premium elite. We're hoping for that holy grail dealer, and that'll be badass. And you know what? That'll be the dealer who has the boom room, where you can come in there and do an A/B listening test between every product. You can understand why you're spending that extra money. Having the test tools, having a tune-up bay, having tweak and tunes. There's a lot of things which should be done. But hey, let's be honest. People just want to make, if it's less work and easy money, well, unfortunately, that's not the way we work here. If it's hard, do it right. Do it right, money comes. And if it's easy, everyone else can do it. Stay away. So it's like a sportsman or any musician or anyone that's practicing to do something. We're all practicing. You keep working at it. In business, you should take that mentality. Keep practicing your art, get on top of your game, and really be a professional and be a winner. When we leave this planet, that's all we're going to have, is to have done everything right and know we made some happy people getting in their car, switching it on, and it sounds just like a rock concert. Just like when you're in the mosh pit and you've got those goosebumps, which are coming again. For me, life's too short to listen to shit music, let alone a badly set up system. So it's a wrap. Hope you guys enjoyed it. I know I ramble on, but there's a lot of information to talk about. Well, I don't want to say ramble on, but I kind of want to get a lot of information out. So if I'm speaking too quickly, sorry, that's me. But time is money, and got to share a lot of information. So if you have any questions, drop it in the comments. We'll probably get to answer every one of them over the next few weeks. And yeah, peace out.